cut it first. So hello, just going back, was there anything above question 6 for that one? And you'll see I probably don't even have to do all of them. We'll just do a quick one. So if we had, just had it on the board before, but back to our old style, if we had a 0 of 3, that seems to be my favourite number today. Let's go -5. So we've got zeros or x-intercepts of those. Everyone is happy, I hope, that that would mean that gives us the factor of x minus 3 and x plus 5. And we must make sure that we put the a out the front and say a does not equal 0, because we could have infinitely many going through those points, skinny, wide, concave, convex, and so on. The problem is that when we have yucky roots, whether they be 1 plus or minus root 2, shouldn't say yucky, conjugate roots, or if it be -3 plus or minus 2i, right? We do not want to do the whole, oh, x take this and x take that. That's just going to be disgusting. So what we do is we do sum and product. And if you were Friends fans and I just said what you do, you'd think Chandler and you'd laugh. But anyway, gap. If I was to expand this one, I get x squared minus 3x plus 5x, so I get a plus 2x. Minus 3 times 5 is minus 15. We're all happy with that. Yeah. If I did this funky little thing where I add the roots together, so we do the sum, 3 plus minus 5 is minus 2, and the product, when we times them together, we get minus 15. And I can do 100 of these if you really wanted me to, and you would find that every time the middle term is the sum, but reverse the sign, and the constant is your product, keep the sign. And that works with conjugate roots as well. So when we now go, let's do the sum, and I don't have to say 1 plus root 2 plus 1 take root 2, because the yucky bits cancel every single time. I just saw a couple of faces, so I will do it. Plus 1 take root 2, right, that's going to disappear, and I get 2. Similarly, tell me what happens when I'm doing the product. I want the name. What do we recognise there? Difference. It's difference of 2 squares. I know you're all being able to do it in your head. So it'd be 1 take 2. So we get -1. And so lo and behold, this would then be y equals, oops, didn't leave room for the a, x squared. Reverse the sign for the middle term. Keep the sign for the last term. And just because I've got it open, we can check that we are right. Equation, poly, degree 2. Oh, what was it? I know it was a 1x. Forgot. -2, -1. -2, -1. And those were our roots, so we know that we're right. And the same thing will happen with the imaginary, okay? The i's will disappear. So for this one, the sum will be -6, because -3 plus 2i, -3 take 2i, and my product, okay, will be 9 positive 2i times negative 2i, so it will give me -4i squared. But the I squared is -1, so it becomes +4. That's right. So we get it's 13, and therefore y will be a x squared. Right, reverse the sign, and then keep the sign, and we're good to go. If I then had, I've got these as my roots, and then I've also got, I don't know, a half. Well, then that would mean it's all of this, but then I also have to times it by, I didn't leave myself enough room there, stick the bracket, and I would also times it by 2x take 1. And if you came in a little bit late, it could also have been x take a half. That would be okay too, but we don't like to have fractions in there. It would just mean that your a value, if you had another point, it would be slightly different. But when you expand it all, it's all good to go. So keep that in mind. If you want to go back and play a little bit when I'm quiet in a minute, go for it. In the past, sometimes roots like this, they're actually easy, but because they're easy, it makes it harder. So when you've just got plus or minus one root, and it's not, so plus or minus, let's do that, I root 3. The sum is going to be, yeah, I don't know why, but sometimes people don't think, they think they've got it wrong if they get a 0, and it's like, no, it's all right. That's good to go. Okay, and then your product, root 3 squared is, yep, 3. And then you've got positive times negative is a negative, but don't forget you've got I squared. So that becomes positive 3. And so this becomes x squared plus 3, put the a out the front and all that sort of thing. And we should go, oh, yeah. If we had made a whoopsie and gone x squared take 3, we should realise that wouldn't give us complex solutions. That would just give me, if I factorise that, x take root 3, x plus root 3. So we're always just double checking. Does that make sense? Yeah. All right, so we're looking at equating coefficients and solving stuff. I've put the example from the textbook there because obviously you see we're trying to find the a, b and c, yeah? And what have they done?
They just use simultaneous. They use simultaneous in the end.
Did they? I don't think so. Oh yeah, they did too. So in this case, what they've actually done is they've expanded the brackets and then they've just equated, right? And they've gone, oh yeah, 4 is in front. 4 is the coefficient of x cubed, so a has got to be 4. Now you are more than welcome to do that. I would like to just show you that you can also find those just by sort of inspection. And this is something that you should have done in methods. So here we go. Done it over here. Got the same thing. Now instead of expanding everything, I'm going to go, all right, I'm looking at my x cubed. On the left-hand side, the coefficient is 4. On the right-hand side, what is the only way, how's the only way that I can get an x cubed? Isn't it only by saying x times x squared? And so that then, x times ax squared, the coefficient there is a. Then we're going to go, let's go the next one, x squared. What's the coefficient of x squared on the left-hand side? 10. We look at the right-hand side. How do we get an x squared? We can obviously go 3 times ax squared, so I've got 3a. But can we also get it by x times x? So we've got this one here, x times bx is bx squared, so plus b. You are more than entitled to expand it if you want to. And then you've also got the option of doing the synthetic multiplication if you want to. There is no do it this way, do it that way. I'm a fan of this because the quicker, it's just quick. And then I've got x squared. Oops, I was talking and writing at the same time, not x squared, it's now x. How do I get an x? Well, it's just the x times the constant term. So c, and is there another x times a constant term? 3b. And the more you do that, the quicker you will get and the more confident you will feel about not missing out any of those. And you can see that we've got this, and of course we've got the constant term right at the bottom. Are the colours freaking you out or do they help? So your constant term on the left-hand side is 15, and we get that by 3 times x, 3 times c. So we get 3c. And then that's a little bit. Oh. Too many C's. C, senor. So you can solve that and get C is 5. Yeah? As we pointed out, if you are left with, multiple unknowns, you're going to have to do a little bit of substitution to get your thing, or your simultaneous blah, blah, blah. But I think they went the sub option. Okay? Does that make sense? I sort of wanted to go straight into question 2. I put question 1 here in case we had a bit of an issue. But with this one, are we like happy to just do it by inspection? So what would your A value be? Yes. What will we do to get the B value? 4 equals, yep. And then solve it, pretty simple. And then obviously C is 5. Got the gist? Okay. So hopefully you don't need to write any of that down. But now let's get stuck in. We're going to do question 2A together. So if you could have exercise 2C, today's date. And we'll keep the change there. Nice. If you're organised with your setting out, it's a bonus for yourself that you can see things, read your work, and it flows really well. If you make an error, it's good for you to then go back and you can see clearly. If it's all over the shop, it's very hard to find that. And obviously for myself, and when I say myself, think of the marker at the end of the year, the exam marker. They don't know you. You're just a number, all right? They don't know, oh, yeah, Tom writes his 7s like this. No. So nice, clear practice. Okay, so my way is, normally I would write z to the 4, but here we've got 1, and of course we've got 1, so that really doesn't give me anything. The more I do, the less I actually write that down. So now we're going to go into the coefficient, looking at the coefficient of z cubed. Now on the left-hand side, there is no z cubed, is there? So we're going to say the coefficient on the left. What's the coefficient on the right for z cubed? In other words, how do we get z cubed? Correct. Z squared times the other z. And so that's the coefficient then is b. So try and not write the bz. We don't care. We've got the z happening here. We're just looking at the coefficients. Okay, and of course, if you can get a z cubed by z squared times z, well, you can also get it by z times z squared. So we've got 0 equals b plus a. And go the next. Z squared.
2 times z squared.
Right, so we've got z squared times the constant, and then we've got another z squared times the constant. So we've got a 2 plus a 2. However, because we've got single z's, we can also get a z squared by z times z. Agreed? Yeah. So a, so plus ab. Ugh. Oh, I've left my, don't forget my 0. 0 equals, sorry about that, for those wanting perfection. If you don't like that, you can put it on the other side. There you go, nice and even. Now at this point, we can actually try and solve because we've got 2 unknowns, but we've got 2 bits of information. And what are our 2 bits of information? Well, from the z cubed, would you agree we have a equals? Minus b. A equals minus b. And so we are going to
substitute that into 2.
So sub into this. I'll just tidy that up a little bit. So here I've got AB equals minus 4. And I'll just stop so you can process and not listen to me. Okay, so sub. So now I've got minus b. I'm going to write it. I probably wouldn't normally write this line in. I'd probably just go straight to b squared equals 4. But you can see now the negatives cancel out and b squared equals 4. So therefore, what's b?
Plus minus.
Oh, very good. You didn't just say 2. It could be plus or minus 2. So we've got 2 answers. And that means that when b equals 2, what's a going to equal? That's simple. And why is that? Because a equals minus b. And when b equals minus 2, then of course a will be positive 2. Me being me, knowing that I make errors sometimes, I would make sure that that is the right solution by finishing off and finding the coefficient of z and making sure that these answers make sure that that is true. Because you will see one coming up shortly where it says show that something can't be done. And so what will happen is your solutions for A and B might work for the coefficient of z squared, but then it won't for z. But I've done this a few times, that's right. All right, we check. Make sure you're answering the question. In this case, it said find the constants A and B. Sometimes it might say find the constants A and B and hence state all zeros in exact form. This is where technology has now gone ahead of some of this stuff, because we all know that we've actually got in our graphics calculator, it can solve polynomials of degree 4. Every year the calculators get better and better, so when they first came in, you could do some quartic polynomials and the exact zeros would never come out. Now your calculator can do some of that stuff. You go, you've got to check all the questions that we did previously, so that you can't just type it into tech. All right, so B is a little bit nicer. It's got values for every single one. So you're confident to have a go at that? I might go slowly behind you and do it. So Z4, bloop. Z cubed, it's got a 1 coefficient here. To get Z cubed, it's Z squared times Z. So that's why I've got the B, and then AZ times Z squared. Z squared has also got coefficient of 1 to get a Z squared times the constant, and then AB. So I'm just going to tidy this up a little bit. So 3, 1 take 3 is, we've got minus 2 equals AB. Okay, and then from this one, we have to now sub. So we've got 2 equations, 2 unknowns. We're going to sub one into the other. So I'm going to take that one and say, what do you want to sub for, A or B? A. All right, so A will equal, it doesn't matter which one you choose. So A equals 1 take B, agreed. So now we're going to sub. So we've got minus 2 B equals B times 1 take B, or 1 take B times, and away we go. So we will have oh, look at that, a friend of ours. B squared take B, take 2. You guys get this? Okay, so nice factorizing. So that will be minus 2 plus 1. And of course, when B equals 2, A will be, pop it back up here, yep, 1 take 2 is negative 1, and when B equals minus 1, A will be 1 take 1, 2. Once again, you should check with Z. So shall we check with Z? Let's do it. Let's just do a quick little check. And when I mean check with Z, I'm checking with the coefficient of just Z. So on the left-hand side, it's minus 9. And to get the coefficient of Z on the right-hand side, how does that go? AZ times minus 2, so minus 2A. Can I get a Z any other way? Correct, 5 times. So that will be plus 5B. Oops. So what I'm really hoping for now is that when I replace A and B with these values, so that's one pair of solutions, and then that will be my second pair, that it will in fact give me minus 9. So doing the little check for B equals 2. Now you don't have to write this down if you're doing a test question or whatever, but you should whack it in your calculator and double check. Okay, so we've got minus 2 times minus 1 plus 5 times 2. Uh-oh.
Yeah, that's something.
So that means what has gone amok? Does not equal minus 9. Yeah. But if B equals minus 1 and A equals 2, what happens there? We've got minus 2 times 2 plus 5 times minus 1, and we get minus 4 take 5. So those are our winner-winner chicken dinner. So sometimes you can have 2 solutions that both will work. Sometimes it's only going to be 1 pair. Capiche? So in a moment you will do 2C, but with this, show that can be factorised into 2 real quadratic factors of that, but cannot be factorised into those 2. So how would we even start that?
Just equate.
Yep, set up the equations now yourself. So z to the 4 plus 64 equals z squared plus az plus 8, and then z squared plus bz. And then you'll do the same for those 2. Practice it again, and when you're finding your values for A and B, stuff will come out. So it's just you're dipping your toe, getting your algebra back up to speed and improving your accuracy. Cheers. As that you progress through this exercise, do as much as you possibly can in the 15 minutes that we have left, and obviously for homework, try and hit an hour over the weekend. We're building up. I know it's a shock from holidays, but got the 3 there. Question 4 and 5 are very similar to what you've just been doing. So once again, they've given you this. They've just added the extra little bit here, hence solve the equation, blump, blump. All that, can you tell me what that is saying?
Let's find the zeros.
That's right, because if you put everything here on the other side, you get this expression. And so the zeros for this will actually be the solutions to that. Does that make sense? Now, 4 and 5 are very similar. So it's up to you if you want to practice with your equating coefficients, that sort of thing. Feel free to do it. It's going to be the same skills over and over again, but they're wording it slightly differently. Okay? So it started off with, here's an expression, this equals this, and now it gets to question 6. I would say it's pretty much the same, it's just worded slightly differently. So now they're saying 2z take 3 is a factor of that. What will you do? Oh. So 2z cubed take z squared plus az take 3. Now that's going to be 2z take 3 times, it has to be a quadratic in there, right? Can I actually have people listening, because there's a couple of things I need to say that's important. So 2z take 3. This then here has to be a quad. I'm not going to put az squared plus bz plus c, because I already know what's got to be here. It's got to just be a z squared. I also know what's got to be right at the end. Plus 1, and the thing that I don't know is in the middle. Now up to you, you can put the A there, or I like to call it B because it's in the middle. Sometimes you'll have multiple, you have to go. This, we're in that zone and we're doing it like this because it's asked us to. Can anyone think of another way to do this?
Yeah.
Oh, look at that. Okay, so you could do the polynomial division. That would be a little bit funky because it's... I'm thinking more of, because this is just one unknown, if 2z take 3 is a factor, doesn't that mean that z equals 3 over 2 is a 0? And so, what does that mean?
That equation has
Wait.
to equal 0. That equation has to equal 0.
When you replace z with 3 over 2. So if you sub 3 over 2 in place of z here, it has to equal 0. Now, we're still practicing the whole thing, and they're going to sometimes get a little bit bigger with the factors that they do. So try and practice this technique, but later on you'll sort of play and they're going to go, oh, now we're talking about zeros, and we'll get to do that. All right. So, but I'm also happy if you sort of go through and you go, yeah, I'm getting this, skip a bit, or if you want to practice some more. Is that all right? Okay, and as you progress, they get a little bit harder. So now instead of one factor, we've got two factors. So the big tip is, yes, factor times factor, but then make sure you expand it from here to here. Okay, definitely expand, and then we know, right, what these ones are going to be because of this value. And of course, -3 times -1 gives you the +3. Good luck.